This video will discuss the solution to question 24. In figure 1, several options are shown how to possibly add diodes to the circuit of figure 4 in order to stabilize the oscillations. Which statement below concerning the diode pairs is not wrong? And then 8 possible statements are given about the diodes. Let's take a good look at this circuit's topology. For example, let's first look at the diode pair D13 and D14. These two diodes are connected between the input and output node of this operational amplifier, of which the output is directly connected to its inverting terminal. And that causes this operational amplifier to be used as a unity gain buffer. In other words, voltages A and B are always the same. And because a diode requires a certain voltage difference in order to turn on, these two diodes will actually never turn on because effectively the voltage difference between the input and the output will always be zero. Secondly, let's have a close look at this inverting terminal of operational amplifier 1. Because the non-inverting terminal is connected to ground, we know that this inverting terminal will be effectively also a ground. It will be a virtual ground. So that means that D9 and D10 are connected between a voltage Vc and 0 volts. And the same thing can actually be said about D11 and D12, because these are connected to the same node if we pass through the loop like this. So these two diode pairs will actually turn on at the same time. And finally, we need to take a close look at diode pair D7 and D8. If the voltage at Vb is large enough to turn on one of these two diodes, an effective short circuit path will be created from Vb to this inverting terminal, because it's given that these diodes are ideal and are modeled as ideal switches. The effect of this on the circuit's operation is really big, because the amplification factor of this last stage, the inverting amplifier, is the same as negative the resistance from the output to its inverting input, which in this case is R5, over the resistance from this inverting input to the input of this amplifier configuration, so that is this node. So that is R4. But if one of these two diodes is turned on, this R4 will be in parallel to a short circuit of 0 ohms. So effectively what you will get is an amplification factor of negative R5 over 0, which will go to negative infinity. So an oscillation with a swing that is large enough to turn on one of these two diodes will actually be amplified even stronger every time it passes through this oscillator loop. And that causes the oscillator to become very unstable really quickly. So the diode pair D7 and D8 will cause the oscillator to fail really quickly. And from that we may conclude that answer F is the correct answer. D13 and D14 would never activate, D7 and D8 would cause the oscillator to fail, and the pairs D9, D10 and D11 and 12 would activate simultaneously.